Named after the Roman god of war, Mars has captivated humanity for ages. The red planet is the quintessential foreign celestial body, and its exploration is currently one of the most significant initiatives in the field of contemporary space travel. Recently, NASA's Perseverance rover touched down on the surface of the fabled planet. The first high-resolution images sent to Earth by the renowned space agency left us speechless, but given the dust-covered surface of Mars, it was easy to assume that the red planet was a celestial body devoid of geological and volcanic activity. However, a recent shocking discovery from astronomers suggests that Mars may still have more life than previously thought. This suggests that Mars still has active volcanoes, and in the next video, we'll show what these might look like and how they differ from Earth-based structures. The reason Mars, the fourth planet in our solar system, has been known as the red planet for so long is evident from just a glance at its surface. The abundance of iron oxide dust, commonly referred to as rust, which covers a significant portion of the planet's surface and is present in its feeble atmosphere, is what gives the celestial body its distinctive red hue. There are no other known rift systems in our galactic neighborhood with such extraordinary values. For example, the Mariner Valleys, which stretch about 250 miles and reach up to 4 miles in depth and are an impressive 430 miles wide, are examples of deep trenches that dwarf anything comparable in our planetary system south of the equator. Historical photographs of the Martian surface taken during various space missions reveal that the planet's hull, which is dotted with craters, has clearly visible traces of earlier tectonics. The remarkable volcanoes on the red planet captivate, with their unfathomable size, and specialists believe that the imposing furrows on the surface of Mars are the consequence of intense volcanic activity. Powerful Martian volcanoes. Let's examine the volcanic monster Alba Patera, a natural formation that rises about 4 miles above the Earth's surface and has an amazing diameter of over 745 miles. Alba Patera is the biggest volcano in our planetary system in terms of size, yet it is unable to compete with Olympus Mons. In comparison, the largest volcano on our planet, Mauna Loa, rises about 2.5 miles above sea level, and the portion below the sea surface is only slightly larger than half the size of Olympus Mons. The reason the highest volcano in our solar system is able to reach such enormous heights must be due to the natural conditions of its home planet, and in fact, the relatively low gravitational pull on the surface of Mars is what spawns such behemoths. The Moon's tower is an incredible 13.6 miles above its dust-covered surroundings, thanks to its unmatched summit height. The scientific community has long lacked any concrete evidence that Mars is still both volcanically and geologically active, but a sensational discovery now suggests that the giant natural formations on the celestial body are still active today. The Tecent meteorite is a significant discovery that suggests that the volcanoes on Mars are still active, even though the scientists agree that the volcanoes have always played a significant role in the geological development of the red planet. If the same conditions existed on Mars as on Earth, Olympus Mons would collapse under its own weight and collapse. Experts researching volcanic activity on the red planet found great assistance from the Martian-derived Tecent meteorite that struck the Earth's surface in 2011. However, the meteorite's olivine crystals caught their attention. The red planet must have been volcanically active when the crystals that were later caught in the meteorite caused the issue, because these crystals normally only form when exposed to rapidly changing temperature conditions, like what we find in lava convection flows. Although the discovery shows evidence of previous active volcanism on Mars, the age of the olivine crystals is estimated to be around 580 million years. Although it is unclear how much of this still remains today, the discovery marks a significant turning point in the study of Martian volcanism. Previously, scientists had to depend mostly on theory, even though the exterior makeup of Mars offered crucial hints. There were few actual volcanically formed Martian samples. The discovery of olivine, which is also abundant in the Earth's mantle, ultimately provided a useful sample that could be used to more thoroughly examine volcanic activity on the red planet. With the aid of this discovery, experts were able to determine that the temperature of the Martian mantle at the time the crystals formed was approximately 2840 degrees Fahrenheit, which is comparable to the temperatures that prevailed in our native mantle. Since Mars likely differs greatly from Earth in terms of plate tectonics, the corresponding temperatures would cool much more slowly than on our blue home planet, the Cerberus-Foci region, which is 4 to 2.5 billion years ago. This situation led experts to once again believe that large portions of the original heat could still be underneath in the planet's mantle. Meanwhile, David Horvath, a scientist at the University of Arizona, and his team presented long-awaited convincing arguments in support of the ongoing volcanic activity on the red planet. They closely examined the Elysium Planitia region of Mars, which is crisscrossed by deep fissures that were once formed during volcanic activity within the Cerberus-Foci rift system, just like many other areas on the celestial body. The specialists discovered a unique crack that instantly piqued the researchers' intense curiosity. More detailed investigations revealed that the corresponding rift was formed no more than 200,000 years ago, and its birth may even have occurred only 50,000 years ago. Thus the rift advances to the youngest known trace of volcanism on Mars. Assuming that the Cerberus-Foci region is the result of volcanic activity, the comparatively young age suggests that the area could be characterized by active volcanism up to the present day. At first glance, the time span of 200,000 to 50,000 years may sound like half an eternity. However, when placed in the overall galactic context, this time frame represents a relatively recent period. The Cerberus-Foci region has been examined in the past at that time. However, experts came to the conclusion that the fissured area had formed 500,000 years ago. At the earliest, in essence, these are former lava plains that cooled over time and changed their shape in the process. In order to determine the approximate age of a Martian region, researchers look at the impact holes that could be found in the area. Using thermal infrared images from the Mars Reconnaissance Orbiter, David Horvath and his team investigated the structural nature of the striking fissure in the Cerberus-Foci area. They were surprised to find that the structure, which is approximately 3 miles long and 10 centimeters deep, has almost no craters, indicating that the trench must have formed relatively recently. The more meteorite craters a region has, the older it is. The findings of the 2018 InSight probe, NASA's InSight probe, touched down on Mars. The lander robot's job was to look into Martian earthquakes utilizing seismic measurement equipment. Within a year, the InSight spacecraft observed 2 earthquakes on Mars after being deployed roughly 1050 kilometers from the Cerberus-Foci area. According to experts, the presence of volcanic activity could favor other astounding phenomena, such as the existence of water on the red planet, which is why the tremors unquestionably originated in the Cerberus-Foci region. This is a conspicuous circumstance that supports the theory that the red planet is still marked by active volcanism. Additionally, the presence of life forms on Mars would be favored by volcanic activity. What information regarding volcanic activity on the fabled celestial body can future Mars missions provide? We at Simply Space are excited for any new discoveries. How did you find our film about Mars volcanic activity? Do you find the red planet as fascinating as we do? Please share your views, opinions, and recommendations in the comments section. Thank you for your interest, be careful, and we hope to see you again soon.